Okay, so we did some math, which is always annoying for somebody who really sucks at math, but we did some math anyway. And we found some interesting things, amongst them the fact that you really cannot find a link for artificial trees to what we meant. I guarantee you they were called artificial trees, and the reason I know this is because I have some games that are somewhat old where they are referred to as artificial trees. But if you go to Wikipedia and look for artificial trees, you will find a very bad technology that's masquerading as artificial trees. I would not touch that technology with a 10 fucking foot pole, so keep that away from me. Now, we went on a little search to see what the current technology is and what its name is and so on. And this is the little downside of being, an interdimensional. You get things like math changing on you and so on and so forth. And the closer it is to you emotionally, the harder it is for it to change. So if you have a record of something that's on a written form and it refers to something that suddenly changed in the internet or the memescape to something completely different, you know what I mean. So the math. This is what we found. Look at this having 921 views in a long time. Now, listen to this very carefully, and I will actually plug in the audio so you can listen to this. This is the most recent data that we could find on this thing of ours. It used to go by the name artificial tree, but carbon capture and resequencing, due to it being more energy costly and therefore more capitalist, has taken over the term. Now, we had to use our standard sidekick to find this. We had to use the Arab civilization to build this again by hand. Thank you, Arabs. Thank you, Muslims. Thank you, Lebanese. We once again had to rebuild the entire tech tree from scratch. And I fucking hate that, but I will continue to do it. So.
These so-called Robo Trees are sprouting up around Mexico's most congested cities. The 4.2-meter structures are designed by startup Biomi Tech to fight air pollution. Although their trunks are made of steel and bands of recycled metal, bio-urban trees do what any regular trees do.
What we have here are freshwater microalgae that have the capacity to absorb carbon dioxide and break down environmental pollutants.
The robo-tree then returns oxygen to the atmosphere. Biomi Tech says one structure can clean as much air as 368 trees. That's about the same amount that 2,900 people breathe in a day. They're also faster to build compared to the time it takes for a tree to grow, but they cost up to $50,000 to produce. Despite the hefty price tag, Biomi Tech has been branching out to install more robo-trees in Mexico.
And that's enough of that one. Here's a little bit of math that we did. And I can do the math again, but I will rather explain it to you and solve the remaining math questions. Now, if we assume one of these artificial trees requires 3 square meters to be efficient, it looked like 2 or 3 square meters to me when the guy was walking next to it. So that would be around 1.5 meters in diameter. We could assume it to be more, but let's go with 1.5. Optimization may change this, and keep in mind that this particular tree design type, how it was built, looked very inefficient. I'm sure your technicians can improve on the design, but let's go with the numbers they provided us because, well, they were the numbers that we were provided with. So if we calculate that it takes 300 of these to fill a square kilometer, and that square kilometer will be, as a result, around 100 times, or what you would in this particular case see as the result. Let's actually do the math by hand to confirm it. Let's do it by hand. 1 tree equals 3 second. 1 tree equals 368 times normal tree. With this, 1 tree costs 50,000. Here is number of urban area. It's 3.629 million square kilometers. Here we go. With one tree taking 3 square meters, and let's assume a normal that what they're talking about is a normal tree also would take 3 square meters, because if it's larger, the normal tree, and thus more efficient, we can build the structure to be the same size and once again as 368 times more efficient. So what we come up with here is how many trees do we need to build to have a significant impact on global warming. If we assume an increase of 10% in tree coverage is sufficient, this is off the top of my head, it might be doubling, it might be anything, but let's assume 10%. So what we come up with here is 10% of trees are 362,900. This would be what we would require for a normal tree. So going by this, we can assume that 368 tree means that we would get, how do we do this? 368 per tree. So to get 10%, which is 3.62 million, we would need about 10,000, which is 10,597 square kilometers of forest. I believe what we are looking for here is, if I'm doing this correctly, 362,900 divided by 0.1. No, that's wrong. It would be multiplied by that's actually completely wrong. 62900 divided by 368. I think I missed the square kilometer conversion. This is why I hate math. I truly hate math, but I must get better at it. So, and besides, that's actually square kilometers, not meters. So give me a moment here. I'm starting my D on math brain. It's it is 3.6 million, which would be normal, divided by 369, which is at this efficiency. I'm pretty sure. Yeah, divided by 368. There we go. So it says we need 10,032, so it's pretty close to what we got last time around. So it's 10,032 square kilometers of artificial trees. And that was actually completely wrong. That was off urban. God damn it. And back to the drawing board. Trees off. I know. Give me a moment here. The upside of knowing that you actually can't do math is that you check everything like a autistic person. That's actually what I'm looking for. Square meter. Actually show the chart. So it's 39. Okay, so 39,958. 3,998. 3,9958. I must have dropped the number somewhere. Seems low, but okay, let's go with that. So, no idea how this math seems to be consistently giving same numbers in the same ballpark. Whatever. Seems to be in ballpark. That's what my math tells me. So now we're talking an understandable number. We're not talking trillions. We're not even talking all that much. We're talking something that, say, for example, the European Union, the United States, China, some of the larger countries alone, like Germany in the United States, United Europe, European Union, could easily do. It's in the feasible range. So let's do one last thing. So by turning 1/334th of the urban environment that currently exists into artificial trees, we would take 10% interest in the ability of the forest to suck up CO2. So that's the math. And thank you for participating in this. And that's about the size of it. We need to have a powwow now with each other and work out some scenarios and who builds what and how expensive it will be and who designs what. I guarantee you these guys ain't gonna build those metal thingies in the middle of every place covertly because people would freak the living shit out. But there are still issues like decomposition of the matter, releasing the CO2 back into the atmosphere, and so on. So I believe that they are saying that even when you calculate all the costs and everything that we mentioned, because it was done by somebody who was talking to us about, or listening to us talk about the different side aspects, like the burying of the topsoil that is now CO2, which they came up with that number. So we need to work up some actual pie charts and statistics, but we are talking 180 billion to get the planetary equivalent of 3 million square kilometers of more forest, in terms of land investment of 10,000 square kilometers. And that would be including end disposal of things. And we are interested in this option, but it requires some work. I believe we can do a good looking artificial tree that is actually more efficient, but that requires some work. I will be getting back to you. Thank you for watching this.